Ang topic natin sa video na 'to ay efficiency of a transformer at different loadings. So, in general, ang formula natin sa pagkuha ng efficiency of a single-phase transformer ay ito. N is equal to PO or yung output power divided by the quantity of PO plus the copper loss plus the core loss. So, isa-isahin natin kung paano ba natin masasolve yung output power, yung copper loss, at saka yung core loss. So, yung output power from the formula of power ng single phase, that is VI, power factor, times X. So, ano naman tong X na nasingit dito? So, this X is the percent loading ng transformer. So, kung gaano kalaki yung load na sinusupply ng transformer, and pwede natin yan masolve using the output VA. So, kung ano yung ina-out niya, kung ano yung output or yung sinusupplyan niyang load divided by the rating. So, kung ano naman ang rating ng transformer. And next, kadalasan itong VI natin, siya na mismo ang volt ampere rating. So, kadalasan binibigay iyan. Next, para naman sa copper loss, that is X square times the copper loss at full load or the full load copper loss. So, pag hindi binanggit yung full load copper loss, baka hahanapin natin siya. Basta't lagi nating tatandaan na yung copper loss na ginagamit natin sa solution natin is yung full load copper loss na naka-times sa percent loading square. Next, core loss. Yung P-core natin na core loss, that is the constant loss sa transformer natin. So, kahit na saang loading, kahit na saang efficiency, ang core loss ng transformer ay hindi magbabago. Let us try answering problem number 1. At full load, the copper and iron losses in a 100 kVA transformer are each equal to 2.5 kilowatts. Sa first sentence na yon, ang data na makukuha natin is the copper loss at full load. Diba sabi? At full load, the copper loss and the iron loss. So, dalawa daw ang makukuha natin sa first sentence and equal daw yon yung copper loss natin at full load at saka yung core loss. Ang copper loss natin is 2,500 watts. So, kapag nagsasolve din tayo pala ng efficiency ng transformer, siguro ang magandang suggestion dito is dapat lahat ng unit of power natin ay in watts. So, ito, ang full load copper loss ay 2,500 watts. Ganun din naman ang core loss na 2,500 watts. Find the efficiency at a load of 65 kVA, power factor of 0.8. So, nagpasolve siya ng efficiency. Para masolve natin yung efficiency, dapat meron tayong PO, P-copper, and P-core. So, isa-isahin natin. Para sa output power, that is VI, power factor, and X. Ano tong X natin dito? So, diba, from the introduction, X is the percent loading. So, kung hindi naman sinabi sa problem kung ilang percent ang loading, pwede natin siyang masolve using the output VA over the VA rating. Ang pinapasolve sa atin na efficiency is when the load is 65 kVA, that is the output, and the rating of the transformer is 100 kVA. Therefore, ang X natin is the output 65 kVA divided by the kVA rating of the transformer na 100. So, cancel na dito ang kVA and ang magiging X natin ay 0.65 or 65 over 100. The power factor given is 0.8 and yung VI natin, that is volt times the current, O kaya, ito naman na ang VA rating ng ating transformer, which is 100 times 10 raised to 3 VA or 100 kVA. So if we are going to solve for PO, that will be 100 times 10 raised to 3. The power factor is 0.8 and the percent loading is 0.65. 100K times 0.8 times 0.65. That is 52,000. This is now 52,000 watts. Next, para sa P copper. P copper is X square, wherein ang X na solve natin ay 0.65 square. And what is copper loss at full load? So, ayan yung binigay sa first sentence natin. The copper loss at full load is 2,500 watts. 2,500 watts. And that is equal to 2,500 times 0.65 square. 1,056.25. And kung makikita natin, yung P core natin is nandito naman na 2,500 watts. So we can now solve for the efficiency of the transformer. The PO is 52,000 divided by the PO. 52,000 plus the copper loss, 1,056.25 plus the core loss na 2,500 and i-times natin sa 100 and our answer will be in percent. 52,000 divided by the sum of the power output plus the copper loss plus the core loss. 2,500 times 100. The answer is 93.599%. Number 2. The full load copper loss of a 75 kVA single-phase transformer is thrice the iron losses. From the first sentence, meron binigay dito na relation. Yung P copper daw natin at full load, that is the full load copper loss, is thrice the iron loss. So, equal daw yan sa tatlong beses ng P core natin or nung iron loss natin. At half load unity, the efficiency is 97%. Determine the full load efficiency at 0.8 power factor lagging. The second sentence, ang sinasabi dito, merong binigay na loading, half load, may binigay na power factor, unity, and may binigay na efficiency, 97%. So kapag ang sinasagutan natin transformer problem ay mayroong dalawang condition, so parang dalawang efficiency ang mga isosolve natin dito, di ba? So ang gawin natin kapag ganoon, ang magandang gawin sa solusyon is ilista muna natin, for example, at condition number 1, ano ang power factor na ginamit sa transformer, ano ang loading, and ano ang efficiency. So at first condition, the power factor is 1, the loading is half load, or that is 0.5 dahil kalahati, and the efficiency is 0.97. So paano natin sila magagamit sa solution ng efficiency natin na N is equal to the output power over PO plus PCU plus P core. So, kung babalikan natin kanina, yung kung paano natin hinimay-himay yung mga formula ng PO, PCU at PCOR, ganito ang magiging itsura niyan. Yung PO natin, ayan ay magiging VI, PF times X divided by VI, PF times X. Yung PCU natin, that is X squared PCUFL plus P core. Diba dito sa pangalawang formula na naisulat natin, pwede na tayo mag-substitute ng mga values using the condition number 1. At condition number 1, yung N natin ay 0.97 equals to VI. That is the VA rating of the transformer, which is 75,000 VA. The power factor at condition 1 is unity, and the loading at condition 1 is 0.5. So, ganun din dito, 75 times 10 raised to 3 times 1 times 0.5. Plus, para naman dito sa copper loss natin, that is X squared plus PCUFL. So, ang X natin is half, 0.5 square. Hindi pa sinabi kung ano ang full load copper loss at kung ano din naman ang core loss. Pero, using the first sentence, malalaman natin that the full load copper loss is 3 beses ng P core. So, we can change this PCUFL as 3 times ng P core. Kaya kung titignan natin sa solution natin, isa na lang yung unknown, and that is P core. Using sheep solve, we can solve for P core. .97 equals 75,000 times 1 times 0.5 divided by 75,000 times 1 times 0.5 plus 0.5 square alpha x or times 3. 0.5 square times yung 3 beses nung alpha x natin, which is the P core, plus yung mismong P core natin. Keep solve, ang masosolve natin is the P core, which is 662.739 watts. 662.739 watts. Therefore, the full load copper loss is 3 times of the P core na 662.739 watts, and that will be equal to 1988.22 watts. So, ito yung purpose ng condition number 1 natin. Makuha natin kung ano yung full load copper loss. Dito sa condition number 2, ang sasagutin na natin is the unknown or kung ano ang tinatanong sa problem. So, at condition number 2, sabi nga natin before tayo mag-proceed sa solution ng N, i-list down muna natin ano ba yung power factor na gagamitin and ano ang loading na gagamitin natin. And since ang N dito ang siyang hinahanap, siya ang unknown, di ba? So, determine the full load efficiency. When we say full load, yung X natin ay isang buo, that is 1, and the power factor given is 0.8. So, using the formula N is equal to VI PF X over VI PF X plus X squared copper loss at full load plus P core. We can now solve for the efficiency. So, mas maganda rin siguro kung ito na mismo yung kabisado nating formula para sa efficiency ng isang transformer. So VI, that is the VA rating of the transformer, 75,000. The power factor at condition number 2 is 0.8 and the loading is 1 over 75,000 times 0.8 times 1 plus yung x square, that is only 1 square. And then yung PCUFL natin, hindi rin naman nagbabago yan because isang beses lang naman din tayo nagkakaroon ng full load, and that is when x is 1. So ang PCUFL natin is 1,988 na nasolve natin sa condition number 1, and the P core is 662.739. So solving for efficiency, this will be our final answer. So 75,000 times 0.8 times 1 divided by 75,000 times 0.8 times 1 plus 1 square times the full load copper loss plus the core loss, 662.739. That is 95.77%. Now this is the answer. Para sa ating last problem, a 100 kVA single-phase transformer has an iron loss of 600 watts and a copper loss of 1.5 kilowatts at full load current. Calculate the efficiency at 100 kVA output at 0.8 power factor lagging, and letter B, 50 kVA output at unity power factor. Sa outlet, ang technique natin sa pagsusolve ng efficiency ng isang single-phase transformer ay ganito, di ba? Before tayo mag-proceed sa pagsusolve ng efficiency N, kailangan alam muna natin what is the power factor na gagamitin and kung ano yung X na gagamitin. The formula for efficiency is VI PFX divided by VI PFX plus X square PCUFL plus P core. So at letter A, ito muna yung sagutan natin at letter A. Calculate the efficiency at 100 kVA output. This is the output X. Paano natin masosolve yung X? Using output divided by rating. So kung ang output natin sa letter A ay 100 and the rating is 100, therefore, we are solving for a full load, and that is 1. The power factor is 0.8. So given naman na yung iron loss and the full load copper loss. So solving for N, that is VI or yung VA rating natin, 100 times 10 raised to 3. The power factor is 0.8. The loading is full load or 1 divided by 100 times 10 raised to 3 times 0.8 times 1. So plus the loading na 1 square and the PCUFL or the copper loss at full load current is 1,500 watts and the core loss is 600 watts. So solving for efficiency, that will be 100K times 0.8 divided by 100K times 0.8 plus 1,500 plus 600. So that is 97.44%. Lastly, at letter B, so ilista ulit natin anong power factor ang gagamitin and ano ang loading. So sa letter B natin, ang power factor is unity. Kaya that is 1. And yung output natin is 50 kVA. So the output is 50 and the rating is 100 kVA. Therefore, ang loading natin ay half or 0.5. So solving for n now using this formula. So kabisaduhin natin yung formula na to. VI, that is the rating, 100 times 10 raised to 3 times the power factor na 1 and the loading of 0.5 divided by 100 times 10 raised to 3 times 1 times 0.5 plus yung x square natin, yung loading na 0.5 square times the full load copper loss na 1,500 plus the core loss na 600. This will be our efficiency at half load unity power factor. 100 times 10 raised to 3 times 0.5 over 100 times 0.5 plus 0.5 square times 1,500 plus 600. So 98.09%.